Now, apart from the properties of conjugate and modulus separately, we are having three more important properties of the complex numbers. So, which will be going to come in any of the question, where we can remember that the sum of the complex number with its conjugate will be always equal to twice the real part of the complex number, which is nothing but again purely real. So, this property can be remembered. The other one is when I take the subtraction. Subtraction means from the complex number, take away the conjugate of the complex number, we are going to get imaginary part. Along with that, since iota is there, we say it as purely imaginary. So, these are two important properties which we will be going to use. We may get few questions in this property when we apply, and this we have already studied, that is product of a complex number with its conjugate. So, these are three important properties which you have to remember for solving the questions. Now, one last part that with which we can solve the questions later on, that is nothing but the reciprocal of a complex number. So, dear students, as we have studied about multiplication, the division is already been taken. Division is a multiplication of a complex number with its what you can say reciprocal. This reciprocal is nothing but it is the multiplicative inverse, because when I say that Z1 is divided by Z2, this is nothing but Z1 is multiplied by 1 upon Z2. This is known as reciprocal, or we say it as multiplicative inverse of complex number Z2. So, we should know the technique of finding the reciprocal. Already we have studied that we have to multiply, we have to rationalize the denominator. This we can remember as, when we say that reciprocal of a complex number, this is 1 upon Z. It is also written as Z to the power minus 1. Let me write this one as Z. And the property that we have studied, if any complex number is multiplied by its conjugate, that means I am going to multiply this term by the conjugate, that means Z bar and Z bar. So, we are multiplying by Z bar and Z bar in the numerator and denominator. What we are getting? We will be going to get Z bar, that is the conjugate of a complex number. In the denominator, we have studied the property. What was that property? That property was Z into Z bar is magnitude of Z square. So, this property we can apply here. This we can remember this one as, this is magnitude of Z whole square. So, do remember this property, because for few small questions, suppose if I ask you, that is if there is a complex number given to you 5 plus 12 iota, if there is a complex number 5 plus 12 iota, write its reciprocal. So, the reciprocal can be written very easily. That means I want to find Z to the power minus 1, we will be writing 5 minus 12 iota whole divided by square of the magnitude, which is 25 plus 144. It's a Pythagorean triplet. So, we are getting 169 in the denominator and 5 plus 12 iota. So, we can write this one as 5 upon 169 minus 12 upon 169 iota. So, this one is the real part and this is the imaginary part with that minus sign. This is how we can do the reciprocal of a complex number. Now, let us take the properties of the addition and multiplication of complex numbers. So, as we are studying complex analysis, means here we are going to have the complex numbers as an algebra. So, all the properties of algebra are valid here. That means, first of all, if I go with the commutative law, so we are having commutative for addition as well as for multiplication. That means, if I say that Z1, Z2, they are two complex numbers belonging to the set of complex numbers, then their addition, whether I am adding Z1 with Z2 or Z2 is added with Z1, the result is same. Whatever you are doing, say for example, if I take a complex number to be equal to 2 plus iota 3 and second complex number as 4 plus 2 iota. So, when you add Z1 and Z2, means I am going to write 2 plus iota 3 added with 4 plus 2 iota will give you 2 and 4 means 6, and when I take that imaginary terms iota, it is 3 plus 2 means I am writing it directly, this is iota 5. If I go with Z2 and then add it with Z1, that is 4 plus 2 iota when it is added to 2 plus iota 3, it is giving you the same result. 4 plus 2 is 6 and iota 2 plus 3 is 5. In both the cases, we are getting the same result. So, that means it obeys the commutative law for addition. Similarly, we can go with Z1 into Z2 or Z2 into Z1. Means multiplication is also obeying the law of commutative property. So, this commutative is valid for multiplication, as well as if I go with the other law, which is associative. Associative means when a complex number, that means here I have to take one more complex number Z3. So, whenever you are adding 3, Z1, Z2 and Z3, we know that we cannot add 3 complex number at a time. Rather, we cannot add any 3 integers or natural numbers simultaneously. First, we have to add 2. So, here either if I go with addition of Z2 and Z1, then with Z2 and Z3, then with Z1, or Z1 and Z2 are added together first and then with Z3, the result is same. So, that is, it obeys the associative law also. Same is the case with multiplication. Z2 multiplied by Z3 and then it is multiplied with Z1. It is giving the same result if Z1 and Z2 are multiplied and then they are multiplied with the third complex number Z3, the result is same. So, when we go for addition and for multiplication, it obeys commutative and associative law. Now, the next one, which is the very important one, is known as the distributive property or distribution law. So, when we say about distribution, means we have to give something to the other side. That means here we will be going to distribute multiplication over addition. As we have done for algebra, it is union distributed over intersection, or intersection is distributed over union. Here we are having distribution of multiplication. So, Z1 is here. If I write Z2 plus Z3, so this distribution is valid, means this dot will be distributed over addition. As a result, we will be getting Z1 and Z2 plus Z1 and Z3. So, this is how we apply the 3 basic laws of algebra, which is commutative, associative and distributive. All the remaining 2 laws were there, which is identity and inverse. They will be going to come later on. So, first let us take these 3 laws, rather these important laws, that is commutative, associative and distributive for complex numbers. Now, let us take now some questions in which, first of all, the question says express the following in the form of a plus iota b. Means this is the Cartesian form, the main important form of complex number, where we have to separate the real part and the imaginary part. Before that, we have to take the help of the operations that we have studied, which is addition and multiplication, but rather here we are having only addition. So, let us take that addition part. So, that BODMAS, that is the basic operation, that is for arithmetic we used to obey that BODMAS, it is applicable. First, we will be going to take care of the brackets. So, let me take the bracket first. So, here we are having 1 upon 3 plus iota 7 upon 3 plus 4 plus iota 1 upon 3. Since outside the bracket we are having plus, it is not going to create any problem to any of the term. And later on that minus is there, that will be going to change the signs in between. That is, it becomes plus 4 upon 3 and this becomes minus iota. So, what will happen? Only the real part. Let me highlight the real part. So, these are the real parts. We will be going to add them first. So, our result will be 1 upon 3 plus 4. And on the other hand, when we take iota common, we are having 7 upon 3 plus 1 upon 3. Clear? So, we are having here 4 upon 3 minus of iota. So, let me take the bracket first. So, here if I take the LCM, this becomes 3, 1, 3 4s are 12. Then plus, again this is iota, this we are having a bracket over here. So, this becomes 3 and the numerator it becomes 8. So, this is how very simple addition we are going to apply. What thing we have to keep it in mind means take the real part separate and imaginary part separate. Now, if I go with the other one, this is 4 upon 3 minus of iota. So, this becomes 13 upon 3 plus 1 iota 8 upon 3 plus of 4 by 3 minus of iota. So, this becomes 13 upon 3 plus 4 upon 3, then iota common, it is 8 upon 3 minus of 1. So, here the result is 17 upon 3 and this becomes 8 minus 3 upon 3, which is giving you 17 upon 3 plus 5 upon 3 iota or iota 5 upon 3. As we have written in the form of a plus iota b, if somebody is asking you to write the real part, it is very easy. The term without iota is the real part. If I say that this is being expressed as z, so real part of z will be 17 upon 3 and imaginary part of z is 5 upon 3. This is how we apply addition in the complex numbers. So, another simple type of question we are taking here, we have to express in the form of a plus iota b, but here we are having a whole cube. So, when I take that whole cube, we are having a formula for a plus b whole cube, which is a cube 3a squared b plus 3ab squared plus b cube. So, this is the identity that we have to apply here. Here, in place of a, we are having 1 upon 3 and in place of b, we are having only 3 iota. So, let us expand it according to that identity. So, when we say about 1 upon 3 plus 3 iota whole cube, this becomes 1 upon 3 whole cube 3 times 1 upon 3 whole square into 3 iota, then 3 times 1 upon 3 and iota 3 whole square and at last iota 3 whole cube. So, when we simplify, this becomes 27. Here this becomes 3 and 1 upon 9 and 3 iota, isn't it? And this becomes 3 and 1 upon 3 and iota square is minus 1 and 3 square is 9. Clear? And finally, this one is 27 iota cube. Iota cube is giving you a minus sign. So, I am writing here minus of iota. Is that clear? Now, what we have to do? We have to separate the real parts and the imaginary parts. Then only we can express in the form of a plus iota b. So, what we will do? Let us write 1 upon 27. Before this one, I will be simplifying it. This will get cancelled. 3 getting cancelled. So, the term that we are having here is only iota, here minus of 9 and then this one is minus of 27 iota. So, let me take the real part first, 27 minus of 9 and then iota is there, we are having 1 minus of 27. So, here if I take the LCM of 27, this becomes 9, 7, 63. So, 6, so this is 18, 18 and 6, 24. This is 1 minus 1 to 4 and this is iota, this is minus of 26. So, that answer that we are getting is 2, 4, 3, rather 2, 4, 2 with a minus sign divided by 27 plus this is minus of 26 iota. So, as I can see that we are having a term without iota, which is the real part, and term with iota is minus of 26. So, we have expressed in the form of a plus iota b. We can write this is a plus iota b. In case they are asking you to write the real part and imaginary part, you can express that. Now, let us take one more interesting question where a new thing is coming, which is real part of z1 into z2 divided by z1 conjugate. And the other one is find the imaginary part 1 upon z1 and z2 conjugate. We will be going to take care about the properties also, but let's first take this simple division and multiplication where z1 is given to you as 2 plus iota and z2 is given as minus 2 plus iota. So, first I will be going to take the product. Let us take z1 and z2 as a multiplication. So, 2 minus iota, when it is multiplied by minus 2 plus iota, we will be going to get, multiply that 2, this becomes minus of 4 plus of 2 iota, this become minus minus plus minus minus plus. So I think you remember about this thing. So let me rewrite it again with the proper format. So 2 will be multiplying by minus 2 plus iota, and minus iota will be multiplying by minus 2 plus iota. So let us write in the proper format of distribution. So when you multiply, this becomes minus of 4, this becomes 2 iota, this becomes minus minus plus and 2 iota. Finally, this is minus iota square. Iota square is minus 1. So this becomes plus 1. So here the answer is minus of 3 and this becomes 4 iota. So we are having the product Z1 into Z2. So this is how we are multiplying the complex numbers. Now the next part. We have to divide by the conjugate. Let me take conjugate of the complex number. So conjugate of this complex number where Z1 is already given to us, which is 2 minus of iota becomes 2 plus iota. So they want you to find the real part. Rather, I will tell you a short technique also, because here this Z1 and Z2 whole divided by Z1 bar, if I multiply Z1 both the side in the numerator and denominator, then you will be going to find there are some properties that can be applied. But I will not be going to deviate on that side. So I will be just taking this one. So here we want Z1 into Z2 whole divided by Z1 conjugate. So when I take this one, so this is minus 3 plus 4 iota whole divided by 2 plus iota. So now we are going to study about the division. Now this will be the first question where we are going to take care about the division. So just watch it properly. So we will be going to take the conjugate here. So let us take 2 minus iota and 2 minus iota in the numerator and the denominator, so that the denominator can become, this is nothing but a rationalization. So here we will be multiplying, this is minus of 6 as we have distributed here, we will be going to multiply these two brackets in the same manner. This is minus 6 plus of 3 iota plus of 8 iota, and this becomes minus, but whole square is there, so therefore it becomes plus of 4. Is that clear? In the denominator we can see this is 2 square. Rather, we are having a minus sign, but iota square is there, so that becomes plus 1, but this will be plus there. So we will be going to have the result as minus 2. This becomes 8, 9, 10, 11 iota. In the denominator, we have 4 plus 1, 5. So we are having minus 2 upon 5, and this is 11. So let me write here 11 upon 5 iota. So we have expressed the complex number in the form of a plus iota b, but they want only the real part. So real part of Z1, Z2 whole divided by Z1 conjugate will be, just take the real part, minus 2 upon 5. So this is how we can multiply a complex number, divide a complex number. Now let us go with the other one, where the other part we have to write the imaginary, but here I will be going to take care of some properties. So imaginary part of 1 upon Z1 and Z1 bar. So we have studied this property. That property says a complex number when it is multiplied by its conjugate will give you magnitude square of the magnitude. So we will be going to write here, this becomes imaginary part of 1 upon magnitude of Z1 square. So when I go with imaginary part of the magnitude of Z1, which is root of, so this is 1 upon root of 2 square, 4, and because how to find the magnitude, I will tell you. For finding the magnitude, we will take square root of the real part. So this is 2 square, 2 was the real part, and the imaginary part is minus 1. So minus 1 square. Rather, here we have to take the square. So I am just putting that square also. So we are getting imaginary part 1 upon, this becomes 2, 4, and plus 1, 5, root 5 square, it is just 5. So here you can directly write the answer 0. You could have written here also, because after applying the property we came to know that this is the magnitude, and magnitude is a real number, it is not having iota. So when there is no iota, that term will be free of imaginary part. So you could have written directly the answer as 0, but we have calculated so that we can understand the concept. So the answer is 0. Let us take a question where we can see that there is a new format of writing the complex number came. That is, instead of writing 4 plus iota 5, they have expressed as a Cartesian point. So 4 comma 5 is another way of writing a complex number, where the second complex number Z2 is given as minus 3 plus 2 iota. So we are having Z2 as a complex number and Z1 as one of the complex number. So we are having two complex numbers with us, and here they are asking you a very simple one, that is Z1 divided by Z2. We have already calculated, we know how to solve this one. So let me write Z1 divided by Z2, which is 4 plus iota 5 whole divided by minus 3 plus 2 iota. This becomes, so I think you might be knowing about this thing, how to do this, because we are having a division. Whatever complex number is there in the denominator, will be going to multiply the numerator and denominator by its conjugate. So let us take the conjugate. So this is iota 5 or 5 iota minus 3 plus 2 iota. This becomes minus 3 plus 2 iota. So rather, same cannot be taken, we have to take the conjugate, means the conjugate will be 3 minus 2 iota. So we are taking minus 3 and minus 2 iota. Let us multiply the numerator and the denominator. So what you will get? You will be going to get 4 into minus 3 is minus 12. This becomes 4 into 2 is 8 minus 8 iota. Then similarly we are having 15 iota, and here you could see we are having a minus sign, but due to that iota square we will be going to have plus. So this becomes plus 5 2s are 10. In the denominator, what we are having, this is minus 3 square. Just we will keep this habit now. Whenever complex number are multiplied by its conjugate, we will be going to get the square of the imaginary part plus square of the imaginary part, real part and imaginary part. So you can see that here we are getting minus of 2. This becomes minus of 23 iota. In the denominator, we have 9 and 4, which will give you 13. So minus 2 upon 13, comma. So first I will write in that form, minus 23 upon 13 iota. So this was not been asked, because here they are asking in the form of the ordered pair. So the ordered pair that we could write is minus 2 upon 13, comma, minus 23 upon 13 is our answer. Let's just search for it. Yes, we got it. Our answer is C. Let us take a question which says, solving an equation is given which is containing complex numbers, that is 3 minus 2y iota is equal to 9 to the power x minus of 7 iota, where iota square, of course, it's an iota. That is having minus 1 as the value. For x and y real we get. So we have to just check what are the values of x and y. So here a simple concept has been taken, that we are comparing two complex numbers, where one complex number will be equal to the other complex number only if when their real parts are equal and imaginary parts are equal. So here we are having 3 minus 2y iota, 9 to the power x minus 7 iota. So when you take the real parts, real part means without iota, should be equal to 3, and the other one is imaginary 2y, that must be equal to minus of 7. So here we are getting 9 to the power x, means 9 is 3 square, whole to the power x is giving you 3 to the power 1. So this is 3 to the power 2x, 3 to the power 1. So we are having 2x equal to 1. So x is 1 upon 2. And when I come to this one, this is y is equal to minus 7 upon minus 2. So first we will search for this answer. So since we are not containing any 7 upon 2 something, so we will be going to find the decimal. So this decimal is 0.5 and this is 6 3s and 0.5. So this is 3.5. Now we have to search for this, whether x equal to 0.5 and y is equal to 3.5. Yes, we got it. So our answer is A. So this is a simple comparison between two complex number where real part and imaginary parts are compared. Let's take a question which is very important. It has came so many times in the examination, where z is a complex number which is given as x plus iota y, and The next part says z to the power 1 upon 3 is a minus iota b. So, I have to get rid of this radical power 1 upon 3. How to get rid of this? We'll be going to do cubing both the side. So, we'll be going to get z is equal to a minus iota b whole cube. Now, you can put the z over here. So, we are having x plus iota y, which is equal to a minus iota b whole cube, and we have just seen that how to expand this whole cube, but here we are having a minus sign. So, I'm just recall that part. We are having a minus b whole cube as a cube, 3a square b, 3ab square minus of b cube. So, this is the identity that we are going to apply here. So, we will be going to get x plus iota y can now be written as a cube, means here a is as it is, I will write a cube. Then we are having 3a square b, instead of b we are having iota b. Then plus 3ab square, so this is iota b whole square. And finally, we are having a minus iota b whole cube. So, this is how we are going to apply this identity. Now, let us simplify. This is a cube. This becomes 3a square b iota. This becomes iota square means minus 1. So, this will be going to have a minus sign, 3a b square. Iota cube is again having a minus, but with iota. So, minus iota, this becomes plus b cube iota. So, let us take the real parts together. A cube, this is 3ab square. So, this is our real part, and take out that iota common. Here we are having b cube minus 3a square b. So, what term we are getting? We are already having our real part. So, this side we are having x plus iota y. What you will do? We will be just comparing the real part and imaginary part. So, what we can see here, x should be equal to a cube minus 3ab square, and y should be equal to b cube minus 3a square b. Clear? So, we can take this a common from here, it becomes, or we want to have this x upon a. So, let us divide by a, that is also same thing. So, we will be going to put a square, that is a will be divided. So, a cube becomes a square, 3b square. And here I want to have b in the denominator because the second part says divide by b. So, we are dividing by b, we are getting b square minus 3a square. Now, finally, they want you to subtract. So, these two terms are subtracted. So, we are having, so now let us take x upon a minus y upon b. So, the result that we are getting is a square 3b square plus, rather no plus, we are having a minus sign, minus b square plus 3a square. This becomes 4 times a square minus 4 times b square, rather we are having now 4 common, it is a square minus b square. Now, I think we got a bit of hint that here they are asking for you to find the value of k, but here we are getting 4. Now, it is clear that value of k is equal to 4. Now, we are having a very nice question over here where c plus iota upon c minus iota is a plus iota b. And where a, b, c are real numbers, then we have to find what is a square plus b square. Rather than going for direct division, here we are going to apply a short technique. The direct division is there with us, we can also divide it and we can get the result, but I will tell you the shortest technique. That means when we write any complex number, that is z is equal to x plus iota y, there is one element which is known as iota y. There is one element in which we get that x square and y square, and that thing is the magnitude. So, after seeing this a plus iota b, and we are seeing that they are asking you to find a square plus b square, we have to take the help of the properties of modulus. So, let us take that one. So, we have a plus iota b, which is equal to c plus iota divided by c minus iota. So, let us take the magnitude, taking mod. This becomes modulus of c plus iota upon c minus iota. So, when I take the modulus means, here the property says, property means Whenever there is a complex number divided by another complex number and we are taking the magnitude, this becomes magnitude of Z1 and magnitude of Z2. This is the property that we have studied while studying that all the properties of modulus. So, we will be going to apply here. So, this is magnitude of C plus iota upon magnitude of C minus iota. So, you could see that the magnitude for this one, it becomes root of A square plus B square, and here it becomes root of C square plus 1 square. And in the denominator again we are having C square plus 1 square. So, you could see that this will get cancelled, and if this gets cancelled, its answer is 1. So, A square plus B square, again squaring both the side, we will write this one as A square plus B square. The result is 1. So, we have completely derived. So, there is no need to worry. We have got the answer as 1. So, we are having a question, very important question, but the importance is actually for the polynomials. Here they have given a value of x which is equal to 3 plus iota, and they want you to cube it, square it and multiply by 8, and here we have to multiply by 3 plus 15. What answer we are getting? So, I will tell you a technique here, because these type of question where x is given as 3 plus iota, I have to get rid of this iota, because this iota is nothing but square root of minus 1, and square root of minus 1 can become rational, means here we know that square root of minus 1, actually we are looking for that square root. So, how to get rid of square root? We are going to square it. So, first I will be writing x minus 3 is equal to iota, then square it, it becomes x minus 3 whole square is equal to iota square. Iota square is minus 1, and this is x square minus of 6x plus of 9. So, that means x square minus of 6x plus 10 should be equal to 0. So, we got a polynomial whose value is 0, and we are looking for a bigger term. So, first I will tell you the basic method where I will be going to divide by this polynomial. I will be dividing this one which is having this x cube minus of 3x square minus of 8x plus of 15. So, I will be going to do simple division, multiplying by x, I am getting x cube. So, this division I think we have studied in junior classes. I am just trying that method first. Then after trying, we will be going to go for some short techniques also. So, we can write this one as x cube, then this becomes minus of 6x square, then plus of 10x. So, when you subtract that, you will be going to get the result here as minus, this becomes plus, this becomes minus, this is getting cancelled, we are having 3x square, now we are having minus of 18x plus of 15. Now, again the division says that we are multiplying by 3. So, I will be going to take 3x square, 3 to the 18x and 30. So, you could see that when we are having this minus sign, cancel it off, we are getting minus of 15. That means this expression, which expression? This x cube minus 3x square minus of 8x plus of 15 can be written as product of x square minus 6x plus 10 by the algorithm of division, x plus 3, and along with that remainder will be added. Let us write plus 15. So, we know that this part is 0. So, this becomes 0, and here only minus 15 is left. So, here you can write the answer as minus of 15. So, this is our answer. But if I go with the long division also, that is if you do not want to go for this one, there is another technique. We will be writing this x cube. This expression can be written as x multiplied by x square minus of 6x plus of 10. You could see that when we multiply this thing, we know that this part is 0. I am multiplying by x and I am getting an expression over here. Then, if I see that x cube is balanced, the next part is minus 3x square. But when you multiply, this becomes minus of 6x square. So, minus 6 becomes minus 3 when you add plus 3. So, I will be going to take 3 here. We are having x square minus of 6x plus of 10. You could see that now 3x square is balanced. Now, we have to take care of this minus of 8x. So, minus of 8x, you can see here we are having 10x, and here when you multiply, this is minus of 12. So we are having this 10x and here we are having minus of 12. So we are having the remaining term. Definitely for the balancing of this part, it will be giving you 15. The same result will be going to come when you don't want to go for this big division. You will be going to left with this term. So here we will be going to have this minus 15 which is common. And then the leftover term, you could see that we can take these two things common from this, which we have already written here 15. So that means I will be going to take x square minus of 6x plus of 10 common from this x plus 3, and the leftover term is minus 15. It will come to the same part. So it depends on you that which method we want to apply. We want to go for the long division or some short techniques, but here the answer is minus 15. Just you have to take care of this thing. Whenever iota some terms are there, take it to the right side and square it to get the result. Let us take a question here. Says this question says, if the conjugate of this product be 1 plus iota, means x plus iota y and 1 minus 2 iota, conjugate of this is equal to 1 plus iota, then we have to get the values that we have to check which of the following statement is true. So when you apply the concepts of conjugate, where z1 into z2, whenever product is being taken and we want to find the conjugate, it is the product of the conjugates, the property we have already studied. So this can be written as x plus iota y conjugate and 1 minus 2 iota conjugate. So let us take the conjugate separately. This is 1 plus iota, this becomes x minus, and this becomes 1 plus 2 iota, which is equal to 1 plus iota. So I want to get the values of x and y. The best part is I will be going to take that term which is containing x and y on the left hand side, rest I will be going to shift. So you can see that when you shift that, what you will be going to get? We are going to get this part where I will be going to do that division where 1 minus 2 iota will be multiplied in the numerator and denominator. So the result that we are going to get is 1 minus 2 iota minus, plus iota, and this becomes minus, but as we are having iota square, it becomes plus, whole divided by 1 plus 2 square means 4. So here the answer that we are getting is 3 minus of iota whole divided by 5. So this is 3 upon 5 and plus minus 1 upon 5 iota. So you could see that x minus iota y, when you compare x, we are getting 3 upon 5, but there is no value. So this will be rejected, as we have seen that for x minus y, whatever result we got, this is also rejected. X plus y, I was not knowing about that, but here x plus y, that thing we have to see. So you can compare with this one. So finally the result that we are getting is something different. We are getting y here. So what I will do, after doing this thing, since we have to check what will be the answer, because one more part is left here which says that x plus iota y. So for verifying this thing, I will be going to do taking conjugate again. So this becomes x minus iota y conjugate will be equal to conjugate of 1 plus iota divided by 1 plus 2 iota. So this becomes x plus iota y, and this becomes 1 minus iota whole divided by 1 minus 2 iota. So we got the answer, but this we could have done it directly also. You can see that there is a property that when you take conjugate of some number, this can be expressed as x plus iota y into 1 minus 2 iota. That conjugate will be taken to the other side. It will be giving the conjugate of the other part, which is 1 minus iota. So we could have got the answer directly as 1 minus iota upon 1 minus 2 iota. This was the result. But why I have done this thing? Because such questions are there where we have to take the conjugates and we have to apply the properties. Rather, both the methods are there with us. You can choose any of the method to get the result. But when we go for the competition exams where less time is given, so try to do these type of properties where a complex number is taken and having the conjugate can be shifted to the other side to get the answer. Now, here is the question which we are just talking about, that is conjugate of this particular number is equal to, is in the form of a plus iota b. That means a plus iota b is conjugate of 2 plus iota whole square divided by 3 plus iota. So, we have to take the conjugate. So, conjugate of the division, the property says Z1 divided by Z2, and we are taking conjugate. This is Z1 conjugate and Z2 conjugate. The second one, when there is a complex number which is having power n and we want to take the conjugate, it is nothing but the conjugate's power n. So, these are two important properties which we can apply here. So, first this will give you 2 plus iota whole square conjugate and 3 plus iota conjugate. So, the result that we are getting is 2 plus iota conjugate and then whole square is being taken, and this is 3 minus iota. So, this becomes 2 minus iota whole square whole divided by 3 minus iota. So, I am just simplifying this thing. This is a square means 4 minus 2ab 4 iota plus b square minus of 1 due to iota square we are having minus. In the denominator we have 3 minus iota. I am going to take 3 plus iota in the numerator and denominator. This is 3 plus iota. So, what you can see here, the answer is 3 minus 4 iota when it is multiplied by 3 plus iota, and the denominator we have 9 plus 1 10. Clear? So, multiply the numerator. This is 9 plus 3 iota minus 12 iota, then this becomes plus of 4 whole divided by 10. So, dear student, when you add the real parts, this is 13, and when you take the imaginary parts, 3 minus 12. So, 3 minus 12 is minus of 9 divided by 10 iota. So, you could see that real part and imaginary part, they are separate, and the answer here is part C. So, C is the correct answer for this particular question.